Testing, testing, 1, 2. Okay, so I've been spending a little bit of time with the sphere generation code, and I actually, because what I'm thinking about doing is I'm going to create a particle system using the geometry shader. One of these books has an example of how to do point sprites instead of using the built-in OpenGL system to just gain more versatility and control over the point sprites to make it yourself in the geometry shader, which I'm going to do because that one's pretty easy. But we're also going to bump it up and we're going to do cubes and we're going to do spheres in the geometry shader. So one of the things I had to do here, and I just wanted to let you guys know, so here's where it controls the complexity of the spheres, this constant variable sphere div, which I can make a variable that's like one of the data elements that's sent in and used by the geometry shader to produce the sphere, each sphere. So here's the vertices and the indices, and I just made sure there was plenty of space there because you can have extra space and not use it, and that's fine. It doesn't. But if you have not enough space and you overwrite it, your program crashes. So anyways, here it is. This is an inclusive loop. They're both inclusive, so it's sphere div plus 1. So I changed the actual sphere creation code and I modified it so that I don't have to change it each time, and it's really just dependent on sphere div plus 1, so I added that into the calculation through each loop in the inner loop. And then I also adjusted the indices. This is not an inclusive loop, and neither is this, so I don't know why sphere div plus 1 works, but it does. You probably don't need that, but anyways, right? Because it's, yeah, am I thinking about that right? Anyways, so it works though. I can show you, but those are the indices right there, and it's in fact, let me just make sure. Does this actually work here if I take out sphere div plus 1? I just want to look real quick. Yeah, they're gorgeous. I don't know why that works with sphere div plus 1. Doesn't it create a empty space or something? Huh. Anyway, so I think that's right. I'm curious what happens if you put in -1. I'm just experimental, just to look, see what happens. That's how you make interesting things, and doesn't do anything. Huh. Oh no, there is a slice taken out of the cube. Isn't that gorgeous? That's gorgeous, and that makes sense too, because what I took out was the indices for that slice. Okay, interesting. Well, that's something you can put into the toolbox like I'm doing here. So I'm just going to leave it sphere div because I think sphere div plus 1 actually creates an empty slice that isn't created. So it just fills it with a bunch of zeros, and there's a bunch of extra vertices around the origin in that particular sphere, which we don't want. So anyways, the other thing that's dependent on the smoothness variable is the call to GL elements instanced. So each instance will draw this number of vertices. Actually, it will use that number of floats. That's how I had to calculate the number to include there, and it's based on the smoothness. So it's sphere div times the sphere div times 6, and that's the number of floats in the indices array, which I should add that as a comment. And let's take out these other ones because at the moment we don't need those at all. We want to separate that, set that up so that looks like that. There we go. So we just add that in and it works. And so now all I have to do is, obviously when I create the function in the geometry shader, I can specify my smoothness of the sphere that I'm going to create right here. So I can go down to 5, and everything is sphere.div dependent now. So the sphere is actually made up of 5 by 5. So 5 going around one angle, 5 going around the other angle, And if we were to draw it in wireframe, you could see all the little dots and stuff. So depending upon how I set this up in the geometry shader later, which is going to be I'm working on this today, so you're going to see me do this today. I probably won't be able to upload it, but I might be able to do that with my phone, which seems kind of cool, but I got to figure that out. So I can send this in as a variable as well. So I can choose the smoothness of each side based on the number of stops that we use to create those little arcs that make up the entire sphere. So 5 by 5 for now sets up 25 points for the sphere. If I put 15, it's 256 points, and the reason I stopped there is 5. I'm sorry. Sphere div, you need to add 1. So 16 by 16 is 256 points to make these really smooth spheres right here. You see, adding the greater complexity will give you the smoothness of the circle. So obviously sometimes I'd want to do that and sometimes I don't. But I have some plans for the geometry shader right here, like ultimate particle system using the geometry shader. So the first thing we're going to do is recognize that we can draw points, lines, and triangles with the geometry shader. Obviously points in a line, all directions, x, y, and z, positive or negative, points in a square, points in a circle. You can actually do points in any sort of order that you want. What we're going to do is create subroutines, and so each one of these options is going to be a different type. And then obviously for the options that have options like direction and positive or negative, we'll just include that as part of if we need an extra variable to be thrown in, that's fine. Point sprite with texture coordinates, 4 vertices, so that's where you create your point sprite. So basically what you're doing when you're creating your point sprite is you're putting a dot there, a dot there, whoops, a dot, what is it doing? A dot there, and then a dot there. So you got 1, 2, 3, 4, and that's your point sprite. And you put in the texture coordinates and the geometry shader will create it all. Excuse me. And then this will be the first face, because the very next, if you think about it, the very next thing that we do, because we can do the same thing with point sprites in a line, in a square, in a circle, whatever we want to program for a subroutine. So then the next thing would be a cube. Okay, so a cube, I'm going to figure out the 15 vertices in the cube, which if you think about it, this would be the first face. So 1, 2, 3, 4 vertices for the first face. Each separate face only requires 2 more vertices because we're going to be using triangle strips, so it'll connect the dots for us. So so that gives you, and you can't just, using a triangle strip, you can't make the whole cube just like randomly selecting the sides. So what I'm going to have to do is do the first 3 sides going around the cube in a circle, right? Because the next side of it would be like you would triangle down or diagonal down and then go up. That would give you the next side, right? And think about it, you just rotated it 90 degrees, but you also created the beginning for your third side. So you diagonal down on that and you go up, that's your third side. Now you're not set up to be able to draw the next 3 sequentially in a row, that the 3 sides that aren't done. So all you have to do is backtrack and set up, or what you would do is you would come across on the third face that you're creating, right? So we're going to double up on one triangle, because once you set another spot, that's another triangle. So we're going to double up on that one triangle, and that will allow us to diagonal and up, diagonal and up, diagonal and up for the last 3 sides. And then once we're done with that, we've got 1, 2, 3, 4, 5, 6, 7, 8, double up, so 9, 10, 11, 12, 13, 14, 15. So that's 15 vertices, and that's where this comes in. So that gives us a maximum of 16 cubes we can do, 17, because each one requires 15 vertices, and the maximum output from the geometry shader amplification is 256 per 1. You send in 1 point, you can get 256 points. So then the next thing is the sphere. So we'd take This is obviously now going to be sphere.div dependent, or the variable that you send in dependent. So maybe we'll go down to 36, which is the initial thing that we tested our example with. You know, we can make spheres with varying complexity. Like this would be 5 plus 1 is 6, so it'd be 36. This is 36 vertices, and it makes a sphere. See how rough it is? Like if we just up it by 1, you're going to get more detail. I wouldn't say that looks so much like a sphere as like a rock, but these look like spheres a little bit better. So 6, 7, so 6 plus 1 is 7, is 49 vertices. Excuse me, so let's go up one more. You know, and I can look for and decide based on each application, you know, the minimum number of vertices versus. So this is 7. You know, it just gets a little bit more smooth each time. And then obviously with the geometry shader, 15 by 15, well, sorry, 16 by 16 because you add 1 to the number. That's going to be 256 vertices. So if you make one of these really smooth ones, that's it per call to the geometry shader. But all you're sending in is a point and some variables like the smoothness and the texture to use, and the geometry shader is going to be taking care of everything else. So that's pretty awesome. Alright, well that's my plan for what's coming up. Stay tuned. Thanks for watching, and I hope to have this video on the internet soon. Thanks. Bye.